So 3.4 is on graphing from vertex form. So just some vocabulary. Remember that a parabola or parabola is the shape of the graph of a quadratic function. So that's that U shape, whether it faces up or down. The axis of symmetry is a line that cuts the parabola in half. So remember, that's an imaginary line that goes right through the vertex point. And so if you fold it along that axis of symmetry, they overlap each other. They would lay on top of each other. The equation of the axis of symmetry is always equal to x is equal to a number. So, and remember that number is always the h value of your vertex. So the vertex is either the tip of the parabola, or you can think of it as the point where it changes direction. So it's where it's going from down, gets to a point, and then it starts going up, or it's going up until it gets to a point and then starts going down. The vertex is also our minimum point or our maximum point. So it's a minimum point if a is greater than 0. And then if a is less than 0, which means it's negative, then it's a maximum point. So again, this means that it's a positive number. This means it's a negative number. And again, we're still talking about the a value out in front. So when we look at a vertex, or the equation of in vertex form, remember it was y is equal to a times x minus h squared plus k. And so this a value in front tells us the direction that it's facing. And then the hk value make up the vertex point. And just the h value is our axis of symmetry. Squeeze that in. Okay, so x is equal to h is our axis of symmetry when we think of it. All right, and those are all things that we've talked about before now, but we're just spending another day. We want to make sure you've got this down. As you look, we have two different graphs that we can have. So we've either got when a is greater than 0, which again, remember that means it's positive. And when that happens, it faces up and you have a minimum point down here at the bottom. And these are your zeros or your x-intercepts, okay? And you can, it depends on what they call them. They might call them the solutions, they might call them x-intercepts, they might call them the zeros, kind of up to you, okay? Or up to whoever's asking. So if a is less than 0, which means your number is negative, then you have a maximum point, your highest point. Okay, so that's the highest y value that you're going to get to. And then these are your zeros or your x-intercepts. And if you have your vertex and your x-intercepts, you can figure out what your u looks like because that's your 3 points. So again, the direction of opening is based off of a. Okay, so it just means, does your parabola face up or down? Okay, and that's just dependent again on A. And then we've got our vertex, which we've talked about. That vertex is always going to be our hk value. And again, we can either solve for h. Whoops, I didn't want to do that. So h is equal to negative b over 2a. And then to find the k, remember we substitute in substitute the h value in for the x's and solve. And then remember your axis of symmetry is x is equal to h. Your y-intercept, you have to put it in standard form first. So from standard form, which means you may have to do some work. So from standard form, which is y is equal to ax squared plus bx plus c. From standard form, it's the number at the end. So this is my y-intercept. And we want to remember to do that. Our x-intercepts, we're going to factor. So the way we find it is we're going to factor from standard form. I'm just going to write SF standard form. Okay, we're going to factor from standard form so that it looks like y is equal to a, and then we'll say x minus D and x minus F. We'll just pick different letters. All right, and so then your x-intercepts are going to be the points D0 and F0, whatever they happen to be when you solve. Domain for a quadratic, remember, is always negative infinity to infinity. If it's interval notation, and it would be all numbers, all real numbers. If it's in set notation. And again, that's just dependent on who's asking. All right, so if it's the computer, big idea is always does set notation. If you do another program, let's say you go to college and you're doing another program, they might ask you for interval notation and you would just put it in with the infinity. And then your range is always going to be, so if it's a minimum, so if you have a minimum point, then your range is going to be from the k value up to infinity. If it's a maximum, so if you have a maximum point, so you have a high point, then it's going to be from negative infinity to your k value. If we're talking about, and this again is interval notation, if we're talking about set notation, then this means y is greater than or equal to k, and this would be y is less than or equal to k, and this is set notation. And so again, you just need to pay attention to which one it's asking for. All right, so with that, let's look at an example. So here's our equation. It's in vertex form. The very first thing that we know is a is 1 because there's not a number in front. We know h is 1 because that's our general form, and k is -4. So remember that the h value is always the opposite of the number that's inside. So it says -1, so we write +1. If it would have said +1, then we would have wrote -1. The direction that it opens is going to open up because a is positive. So it opens up, and your vertex is the hk value. So our vertex is 1, -4. And then is it a max or a min? Well, because it faces up, it's a minimum. The axis of symmetry is x is equal to 1. And those are all things that I could graph right now. So I can go over 1 down to -4. I can draw my axis of symmetry, which is going to go through the middle. Whoops, it's off a little bit. So this is my axis of symmetry. And then we can see what else we can figure out. We know that it's going to go up. We don't know exactly where it's going to cross, but we do know it goes up. So if I want to use the y-intercept to graph it, then what I need to do is I need to figure out what this equation is in standard form. And the easiest way to do that is to multiply, remembering that this 2 means that there's 2 of them. So this is x minus 1 and x minus 1. So x times x is x squared. X times -1, -1x. -1 times x, -1x. -1 times -1, +1. And then we're going to substitute that value. So when we solve, we get x squared minus 2x plus 1. That's by combining these two and adding them together. And then what we have to do is we're going to take this value here and we're going to substitute it into this spot. And so really this is the same thing as going x squared minus 2x plus 1, and then the -4 at the end. So these are the same thing. And then I want to make sure that I simplify. So when I simplify this, I'm going to get x squared minus 2x plus 1 minus 4, which makes this end. So really, let me erase that. So really what happens is I'm going to combine these last two numbers because I don't have to distribute anything. So if I pretend that the parentheses are not there, then this is really x squared minus 2x plus 1 minus 4. And this part I'm going to combine. So 1 minus 4 makes it so I've got a negative 3 here at the end. Now, if I had an a value that was something other than 1, then I would have had to distribute before I can combine those last two numbers. But this number at the very end is my y-intercept. So my y-intercept is 0, negative 3, which I can graph. So 0, negative 3 is here. It's one space away from my axis of symmetry, so I know there's another point on the other side, and then I can just connect. Now, it's just a guess, right? We don't know exactly where it's going to cross because I didn't solve for my x-intercepts. So when I look at this picture, I don't know what my zeros are for sure unless I factor. And you can factor, which is not an issue. That's fine. But we didn't, so we're going to just go from there and assume we're fairly close, all right? Because we've made our curve go up using the 3 points. Remember, we always need 3 points to make a nice curve or a nice graph. So our domain, again, is negative infinity to infinity, or all real numbers. And again, dependent on if we're doing it on paper or on the computer, or if we're doing it on Math Excel or Big Ideas or Lumen, like depending on the platform that you're putting your answer in is going to be dependent on which method or which form they want it in. And you just need to make sure you read. Our lowest y value is negative 4. So it's going to go from negative 4 and then it's going to go up forever to infinity. And the other way we can say that is our y values, because these are our y's going up. Our y's are going to be greater than or equal to negative 4. And either one of those would be correct, just dependent on what it's asking. If we look at example B, same idea. We've got A is negative 2 because that's the number in front. H is the opposite of what's inside the parentheses, so it's positive 2, so we're going to write negative 2. And K is negative 1. The direction of opening is based off of A, so because A is negative, it's going to go down. And our vertex is negative 2, positive, or negative 1, sorry. And then it says, is it a maximum or minimum point? If it goes down, then it's going to be a maximum. Our axis of symmetry is going to be x is equal to negative 2. And then we have to solve to get our y-intercept. So let's just go to there. We know a couple of things. We know that our vertex is at negative 2, negative 1, which is here. We also know that our line of symmetry is going to go through that point. And those are those two things. That's our vertex and our axis of symmetry. To find the y-intercept, we have to do a little bit more work. So we can do the box to multiply. And so this power 2, remember, means there's 2 of them. So this is x and positive 2 and x and positive 2. We multiply. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. We'll combine like terms, which is adding these two, which is x squared plus 4x plus 4. And now we're going to take this and we're going to substitute it in for this little chunk of parentheses. And so I'm just going to do that below. So I've got negative 2, and instead of writing the x plus 2 squared, I'm going to write down what I just got, which was x squared plus 4x plus 4. And then it has a minus 1 at the end. And so this is my, it's an f of x, not a y. So this is my new function, and it's just written in a different way. It's the same exact equation, just written in a different form. So the next thing we're going to do is we're going to do distributive property to everything that's inside parentheses. So this is going to be negative 2x squared minus 8x minus 8, and then this minus 1 is still there. And now we're going to combine like terms. So we've got negative 2x squared minus 8x These two are going to combine because they're both constants, and we get -9. This value here at the end is our y-intercept. And so our y-intercept in this case is going to be the point 0, -9. And so when I graph that point 0, -9, it's going to be off of our graph just a tad. So we're at -6, -7, -8, -9. So we're going to do our graph right here. Sorry, that's in the middle of our picture. And we are going to connect. Okay, so that's our, oh, sorry, I lied to you. That's on the y-axis, not there. So it's our y-intercept. Maybe I should have thought about that. So it's right here, that value that we got to. Notice that that's 2 places away from our dashed line, which is not going that far. Let me see if I can move this. We can scoot this down. There we go. All right, so let's see if that's gonna be a little bit better for us. All right, let me erase. Oh, whoops. Let's go to the eraser. Okay, there we go. All right, let's make this go down a little bit further. We'll ignore this for just a second. All right, and so as we look at our points again, we've got -6, -7, -8, -9, if we extend this line. And that's again 2 spaces away. So we're going to go 2 spaces away on the other side, and that's going to give us our u. All right. And so when we look at domain is still -infinity to infinity, or all real numbers. And then the range, because it goes from the bottom to the top, is going to go from -infinity up to -1, which notice again, excuse me, that's the x value of our vertex, or we can write that as y is less than or equal to -1. And that would be all of our examples for this. So if you have any questions, make sure you ask. Again, we've kind of been doing this a little bit. This is just having a small graph with just our vertex point and our y-intercept and its reflection, which makes it a little bit easier than having to factor each time. All right, I will just talk to you guys later.